The recording, that's why I don't want to stop the recording. Okay, let's share my screen. Okay. Okay, so do you see my screen, by the way? Do you
Yeah,
see
I
my
can see
screen?
it.
Okay,
Yes.
all right, excellent.
They want to draw conclusions about, while sample is the smaller group of individuals you
Okay,
actually collect
let's
data
start.
from.
Let's start.
Your research design should clearly define who your research will focus on and how you go about choosing your participants. In research, a population is the entire group that you want to draw conclusions about, while sample is the smaller group of individuals you actually collect data from. In this video, I'll explain how to define your population and introduce you to some strategies for selecting a sample. Hi, I'm Jessica from Scribber, here to help you achieve your academic goals. First, it's important to clearly define the population you're interested in studying. In research, a population can be made up of anything you want to study: plants, animals, text, organizations, countries, etc. But in the social sciences, it most often refers to a group of people. Will you focus on people from a specific demographic, region, or background? Are you interested in people with a certain job or medical condition, or users of a particular product? Here's a tip. The more precisely you define your population, the easier it will be to gather a representative sample. For example, if you're studying the effectiveness of online teaching in the US, it would be very difficult to get a sample that's representative of all high school students in the country. To make the research more manageable and to draw more precise conclusions, you could focus on a narrower population. Let's say 9th grade students in low-income areas of New York. But that's still a lot of students. Next, you should consider how you select a sample from this population. To select a sample, there are two main approaches: probability sampling and non-probability sampling. Probability sampling means the sample is selected using random methods. It's mainly used in quantitative research. Non-probability sampling means the sample is selected in a non-random way. It's almost always used in qualitative research.
Can you get rid of the black square? Oh, thank you.
Quantitative research. The sampling method you use affects how confidently you can generalize your results to the population as a whole. Let's take a closer look at these two approaches. Probability sampling helps ensure that your sample is representative and unbiased. With this type of sample, you can use statistics to draw strong conclusions about the whole population. There are various methods of probability sampling. For example, with simple random sampling and systematic sampling, you select a sample completely at random from the whole population. With stratified sampling, you divide a population into subgroups and draw a random sample from each subgroup. With cluster sampling, you divide a population into clusters, for example, geographical areas, and randomly select some of these clusters for your sample. Probability sampling requires that you have a list of all potential subjects or cluster in the population. That means it's often quite difficult to achieve in practice unless you're dealing with a very small and accessible population. In our example, you could use cluster sampling. First, you compile a list of all schools in low-income areas of New York, and then use a random number generator to select a sample of schools to collect data from. Non-probability samples are much easier to achieve, but they have more risk of bias. If you choose a sample based on the most convenient and accessible members of the population, or if you rely on volunteers for your study, your sample might differ in systematic ways from the population as a whole. For example, high academic achievers might be more likely to volunteer to take part in an online teaching study than students in general. In this case, your results would be biased towards students who already tend to have higher grades. For practical reasons, many studies end up relying on convenient sample, but it's important to be aware of the limitations and carefully consider potential biases. You should always make an effort to gather a sample that's as representative as possible of the population. Check out our article to learn more about common methods of probability and non-probability sampling. In some types of qualitative design, sampling may not be relevant. For example, in an ethnography or case study, your aim is to deeply understand a specific context, not to generalize to a population. Instead of sampling, you may simply aim to collect as much data as possible about the context you're studying. In these types of design, you still have to carefully consider your choice of case or community. You should have a clear rationale for why this particular case is suitable for answering your research question. For example, you might choose a case study that reveals an unusual or neglected aspect of your research problem. Or you might choose several very similar or very different cases in order to compare them. Once you've defined your population and have an idea of how you select your sample, it's time to decide on the methods you use to collect data. See you in the next video!
Okay, that's excellent. Let me.
Is this video going to be posted on is it on the slide, or is it going to be available for us to watch whenever?
It's already on the slide.
Okay.
All right. So, what is your take on the video? Did it help to explain what a sampling is to you? What are some of the difficulties that you encounter within in the video? Do you need me to explain? Okay, I have to do this properly. Let me stop sharing. What is your take on the video, first of all? Anyone?
It was helpful, thank you.
Helpful? Okay, how helpful?
Sometimes it's just easier to grasp the concepts with some visuals, so I appreciated that.
Okay.
I know that we're going to go through this more throughout the lecture, so I'm looking forward to knowing more about the case selection. But as far as like probability and non-probability, it made it pretty clear.
Wonderful. Any other questions? Comments? Suggestions? Okay. If no questions, no comment, let's go for 10-minute break. It's now 8:07. Come back at 8:17 so that we can just run through it quickly. So don't log out. I will take attendance whilst you are going for break. So don't log out.
I have a quick question for the final assignment, the group assignment. For the 9 to 10 pages, is the title page and the reference inclusive, or just the
No,
proposal?
not inclusive. Not title page and reference are not part of it.
No, okay, so just the proposal itself, right?
Yeah, that just the proposal, yes.
Okay, thank you.
Thank you for thanking me. Okay, you can go for the break. You can go for break and then come back. 8:17.
Professor, can I just
Yes.
ask you a question?
Good.
Sorry, this
Go
is
ahead.
Shay. I sent you an email about the not receiving feedback on the last assignment. You said that maybe that the Word document wasn't compatible, but I didn't see any new uploads on my feedback page.
Our group also didn't receive their feedback.
There was a feedback. I don't know what's okay.
All of our group members checked and none of us got the feedback on our grade.
Yeah.
There should be. So what's your name?
I'm the one who submitted, and it says in the feedback section, check with the person who submitted, but it was
same. Our group has the same issue.
Okay. I was
Maybe
just
there
hoping
was
that
a convention
we
or something.
could try
So
to fix
just
this
email me
before
again, okay? So let me
Sorry.
Check. Maybe I have to
Okay.
save it in a Word 2003 also.
Okay.
So email me again, okay?
Okay.
No.
Yeah, I'm just we want to make sure that we yeah, I can fix our mistakes for the next assignment.
Yeah, you need a comment.
Yeah. Thank you so much.
Yeah, no problem. Thank you too.
Dr. Demi, I believe one of our group members also emailed you regarding that as well. None of us have the feedback on our grade.
Okay. I'll check. There are feedbacks. Probably I mean it happened sometime. Maybe the
Dr.
price
Demi?
may kind of change something. So I'll check it and then probably maybe save it in the Word 2003 or lower versions of it.
But do you put the feedback in Brightspace or do you put it on the document that you send back
On
to
the
us?
document, on the document.
Okay, because I got the
the reason
feedback.
when I download, it tells me convert it, right? So
Yeah, we didn't get it on the actual document either.
yeah. So I'll check and then get back to you.
Thank you so much.
No, that's okay. Mary.
Dr. Demi, for the exam, is it Guardian you said to download?
Guardian browser, yes.
Guardian browser? Okay.
Yeah, okay. I will send the manual to you. I think most of you even have it already, but I will send the manual
It's
so
in
that
the
you start
manual
early.
because I do see it on Brightspace. I can look in the manual. I do see it. It's in there.
Do you see it?
Yeah, I see it on Brightspace. Like the manual is the browser in there, the one that I need to download?
Yeah.
Okay.
Yes.
Thank you.
It's in the Brightspace, yeah.
Okay.
But
Thank you.
I'll send it again in case of if
Per-
someone is missing something.
Professor, you're still sharing your screen just in case you're looking up confidential things.
Oh, okay. Let me stop. I'm trying to. Oh, sorry. Let me see. Where is the Zoom link? Okay. Oh, I only see. Okay, stop sharing. Okay. Okay.
Sorry, Dr. Demi, I know you might not be looking at the Zoom screen right now, but it's Olivia. I'm just wondering if you want me to just email that piece in.
Yeah, the work that I did, or what?
Do you want me to just email just because I wasn't able to participate in the group, do you want me to just email you the individual work for the group work for tonight?
Oh, no, not necessary.
No?
Yeah, not necessary.
Okay.
The group work, I'm not going to give any marks for that.
Okay.
I'm just going to share. Okay, you can, if you have done something, you have a question that
I was gonna say I did do it all, so I
Okay.
Okay.
If you've said some question, you can give it to me so that I'll share it with the group. Okay.
Okay.
It's time. Let's start. Welcome back. Those of you who are here, thumbs up. Let me see if you are around. Yeah. Okay, so I'll run a little bit faster today. Today we are going to discuss what I call sampling, right? As I mentioned at the beginning. Sampling is very, very important in research because ideally you should be able to, if it's possible or it's preferable, if you can interview all the population, right? You can interview all members of the population, but for practical, logistic, and financial reasons, it's not usually possible. So therefore, you have to select a sample out of the population. So now let's begin with some terminologies, right, that are associated with sampling. We are what we call the population. So this is the group you are going to investigate. So for example, when I talk about, let's say, nurses in Sault Ste. Marie, right? This includes all the nurses in Sault Ste. Marie. If I want to be more precise, I have to narrow my population. So for example, female nurses. So it means that I've excluded male nurses. And in this case, I've narrowed down my population so that I'll be able to be more precise in generalizing my findings. I can also say, for example, Black nurses, white nurses, female, male. So the narrower the population is, the more precise you can come out with your findings. So let's look at some terms that are associated with research. First of all, we have the population, which means the entire group of units about which references will be made. Then in the pool, for example, in election, when we talk about population, we are talking about the registered voters, people who have registered. So those who, have not registered, right, cannot, because at the end of the day, they will not vote. So they cannot be part of the population. Then we have sample in its literal sense. We can say that it's a unit measured or surveyed. And then we have census. Normally, it's taken by, for example, every country. Every 10 years, there's the need for census. So census means the entire population. So note the difference between census and then the poll, political poll. For census, takes count or enumerates all the entire population, children, adults, whatever. But with the poll, political poll, only people who have registered or people who are at voting age. So let's get that also straight. Then we are what we call sample survey. So basically, as the name suggests, a subgroup of large population question on set of topics, right? You can sample an individual and the person may decide not to take part in the study. So that will not form part of the sample survey, right? So let's know that. Any questions so far? Any questions, comments? All right. So there are two main types of sampling, as you all know, the non-probability sampling and the probability sampling. So let's start with the non-probability sampling. So with the non-probability sampling, we have several names for non-probability sampling. So for example, we can call it convenience sampling, availability sampling, accidental, quota, and so on and so forth. This may provide insight, but cannot state that the sample was scientific. Right? At least it can give you an idea of a direction of a research, but you cannot use it as a scientific sampling. Easy to conduct. less involved and cheap. Won't need to create sampling frame, right? With the non-probability convenient and whatever, you don't need to create sampling frame, right? Sampling frame is basically the population from which you are going to sample, right? There's no need to create that. It provides quick estimate, but not accuracy and precision. Is that all right? Yeah, and so on and so forth. So let's look at an example. Example of convenience sampling include, for example, approaching people at a mall, right? And then you decide, okay, the first 10 people that I'll meet there, I'll interview them, right? Or minister attending a meeting or a group on a tour. You just meet people and then you interview. Because the selection is not random, right? Later on, we will define what a random sampling is. It is impossible to know how well the true population is represented. So the whole idea is that it is likely that your sampling may skew towards one particular group. Is that right? So maybe you want to find out the number of people, for example, or people who like soccer, people who like football and whatever. And then without random sampling, you just interview people. There's the possibility that all the people or most of the people that you interview will be soccer lovers or football lovers. So that will not represent the general population, right? Non-probability sampling, not generally viewed as scientific. Article mentioned that results regarded as preliminary or exploratory than definitive and can be very informative, right? Informative. So these are some of the characteristics of non-probability sampling. Now let's look at some of the types of non-probability sampling. The first we have is typical case. So the typical case is normally when you are looking for the average, right? So for example, let's assume that you want to look at student attendance, right? And its effect on performance. So when we talk about a typical case, it means that you are looking at somebody who has an average attendance, not too low, not too high. Is that okay? That can give you a clear sense of the direction. And this typical case may provide good info or information about the average client, but perhaps not typical client, right? And don't provide a cross section of cases. So it doesn't give you the various possible cases that you may encounter. Any questions so far? Oh, sorry. Any question? Then we have purposive. Purposive or purposeful. Both are correct, right? So purposeful sampling, as the name suggests, is a group that has certain characteristics of interest or in common, right? So you want to, let's say, investigate the experiences of people who, or how people deal with grief. Is that right? Of course, you may want to select people who have experienced grief and you want to know how do they deal with the grief, right, during that period. So you are going to select people that have the information that you are interested in. It's better designed than random sampling when there is an identical problem, but no claim can be made that the larger population is represented. Snowball sampling are purposive sampling. that grow from respondent recommendations or referral. So another purposive sampling is also, snowball sampling. So here you identify an individual who has or possess the information of interest that you are interested in. You interview the individual, then you ask the individual to introduce another person that may possess the same information. And normally, this type of sampling is done when the population is not open, right? When population is not open. So that's how you'll be able to get, especially when you have difficulty identifying the group that possess, for example, the characteristics that you have. And this type of sampling was used in the past mainly with the people that identify as maybe same-sex couple or whatever. So when you interview one, you ask the individual to recommend somebody that may be of interest or has the information that the researcher is looking for so that the person can interview.
Sorry, Dr. Demi, may I?
Yes. Yes.
So that example you just said, is that a form of gatekeeping as well? Because that person that gave you your initial response is kind of opening the doors to the community that might be worried in speaking with you?
Yes, absolutely.
Okay.
So, the referral is to build trust, right?
Yeah.
So normally when you refer somebody, it means that the person know that, okay, if this is the one referring you, then it means I'm safe, right?
Right.
So
right.
absolutely,
Okay.
absolutely.
Okay, thank you. I'm just trying to make sure I understand all these terms that we're.
Yeah, that's very important. Good. So then we have what we call the maximum variation or defiant or extreme case sampling. So this is also type of purposive sampling, and the approach can be used to determine if various agency sites have similar or different problems. So what is the deviant case? So you are looking at the extreme, right? An extreme cases. So let's take, for example, you want to investigate causes of divorce, right? Causes of divorce. And you want to interview somebody with extreme case. So for example, somebody who has divorced maybe 5 times, right? So it's beyond the average or the normal. Is that okay? So this one is what we call the extreme. Or if you want to study about grief, you want to look at somebody who has experienced some severe grief that is beyond the normal. So for example, somebody who has lost both parents or whatever in an accident. This is not usual, it's not normal, right? So that's an extreme case that you want to do. So used when population characteristics are not known or when only small samples are available. Then the maximum variation evaluator look for extreme at either end of the range of the client experience. And then the deviant case or extreme case, an evaluator deliberately chooses cases that don't fit the normal, right? Individual longest experience of homelessness. So these are an example that we can talk about. Any questions so far? If I'm going too fast, kindly draw my attention, okay? All right. Then we have quota sampling. So an attempt to be inclusive or politically correct without using the random sampling, right? And an arbitrarily identical sample size is collected from each of the group and then used in some groups, being oversampled and others being undersampled. So basically, when we talk about quota sampling, you are trying to make sure that the sample is representative. Is that all right? So assuming you want to interview Agoma University students, right? And then let's say 2 groups of students. we have the social sciences, which include social work, humanity, sociology, and all that. And then we have physical sciences, which include biological science, physical, and others. But when you check the registrar or you check the student population, you realize that, let's say, social sciences are 400. The number is 400. But the physical sciences are 600, right? So now you have to give quota, right? You have to develop quota. Normally, it is done using the population ratio, so that you select the 400, those that are 400 will be lesser than those that are 600 because of the different population size, so that at least your sample size will be, representative, right? Any question? Okay. So difficult to know if findings are representative of the, findings are representative of the larger population client. Sorry. So these are some examples of sampling and explanation. So for example, you can extreme cases or deviant cases. Then the explanation here is offering good example of the phenomenon being calculated. So these are just information that you can, look at it later on. Now let's look at the probability sampling. So probability sampling basically means that you want to give each individual, right, or each item in the population an equal chance of being represented, right? So in this case, you use what we call, there are different types. The most common one is the random sampling, which we'll talk about now. But let's look at the principle. Probability sampling has to be what? Has to be a list of every possible respondent or client. So let's say you want to study the experiences of nurses in Susemeri, right? So you have to get the list of all the nurses possible. Then every person in the sample frame must have an equal chance of being selected. So the way you select out of the entire population, each individual should have equal opportunity of being selected. So basically, it's the lottery system. So let's assume that you check, and then let's say there are 100 nurses in Susemeri. You have their names, right? And how to conduct random sampling may involve, maybe you write each one, you write their names on a board, right? And put it in a system. Or you write each one of them their name into a random generator. There is, a website that can generate that. You write each name, or you assign number to each member, right? And then you click the random generator, then the random generator will generate, maybe if you want 30, so it will generate 30 numbers. So you look at the numbers and you look at the corresponding name, look at the numbers and then corresponding name. Or let's say in this class, I want to do a random sampling here. Let's say the simple random sampling. I can write your name, all of you, your name, on a pieces of paper and put it in a bowl, shuffle it, and ask people to pick one after the other. So let's say you are 40 here. I want only 10, right? 10 individual. So I have to write the names of all the 40 students and put them in a bowl, and then ask one person either to blindfold the individual so that the person cannot be biased or whatever, so that the person will just shuffle and pick one. So when you pick one, then I'll use the one that you pick. If 10, the 10 will be the sample. This means that each member or each student has equal opportunity of being selected. Any question? Any questions so far? Okay. So, it allows you to set and then know the margin of error around each of the findings and then the level of confidence that you can place in the findings. So basically, we'll look at it later on. This is mostly in quantitative studies, right? We have some level of margin of error. We have 10%, 5%, and the 1%. So the 1% is the ideal, 5% is allowed, but 10% is a little bit not, well accepted. So when you have a margin of error of 1%, meaning the confidence level is what? 99. Right? When you have a margin of error of 1%, meaning the confidence level is 99. When you have a margin of error of 5%, the confidence level is 95. So if you have a margin of error of 10, what will be the confidence level? Anyone? If you have a margin of error of 10%,
About
what would be the...
Would it be 90?
90, yes.
90.
So you have 90, yeah. So the confidence level will be 90. We will get to know this when we use the system to generate the sample size. So now let's look at the types of random sampling. I think the simple random sampling I've already explained, which I use, the classroom as an example. The idea is that you should give every member of the population equal opportunity to be selected. That's the main goal of the random sampling. Let me see. Choosing through a free process, this is just information for you. Now let's look at the systematic random sampling. This is it's also random sampling, but it's slightly different. So systematic random sampling is type of probability sampling in which every unit or individual is selected according to predetermined sequence from a list, right? So assuming this class, let me use this class as an example.
Can I?
You have 4.
Sorry.
Yes.
Yes. Could I use an example just to make sure I understand?
Okay, go ahead.
So the systematic random sampling would be like if you're trying to get a percentage of like sports injuries in your school, so you'd be gathering data from every sports team, and then the random cluster sample would be taking all of those sports teams but polling soccer, rugby, and basketball only.
That would be the cluster.
Yeah, that's what I said. So the first one, the systematic is all sports teams, and then the random cluster sample is polling certain sports teams instead of all of them, right?
Yes, exactly. Yeah.
Okay.
So let me explain the what do you call the systematic. So systematic, let's say in your classroom, I have the register, right? From let's say 1 up to 40, right? I have the list. Then I can decide that I want an interval of 5, right? I want to select an interval of 5. So the number 1, number 2, up to 40, right? Then I have to determine where should I start. So let's assume that even I can close my eyes and put a pencil on each number. So let's assume that I put my pencil or pen on number 5. Means I'm going to count every 5 items I'm going to pick them as part of the sample. Is that right? So if let's say I start with, let's say number 3, right? Or I can use the Ludo dice to just roll it out and then say, okay, I'll start from number 3. So if I start from number 3 and I'm taking 5, which will be the next number that I'll take?
6.
5.
8.
So 3, 4.
8.
Okay. 8. Exactly. So the next number will be what? Another 5.
13.
13. Okay, that's good. Okay, let's say I want to take 10th item, right? And I started on 20, number 20. Which will be the next item that I'll pick, or individual that I'll pick?
30.
30. Wonderful. The next one?
40.
40. And then, 40 is the last. So I'll still go from the 40, from 1 up to what? 10, right? And so on and so forth. Until I'll do that until the number of, sample that I want to, or the number of people that I want to select is reached. Is that okay? So then I think I'll stop. So that is the systematic approach. Then we look at the cluster sampling, right? It involves identifying clusters of individual, randomly selecting from those clusters, and then survey individual within those clusters. What do you call? Actually, rightly mentioned. I want to look at the sports injury. So I'm looking at basketball, volleyball, whatever. They are in the clusters, right? And I will decide to, okay, let me randomly select any 2 out of the clusters. I may either select volleyball and basketball. And out of the volleyball and basketball, then I'll randomly select the individual 4, right? Or I can place them based on geographical location, right? Let's say those in Timmins, one group, those in Susemeri, one group, those in Brampton, one group, and those in, let's say, Thunder Bay, in one group. Then I'll randomly select 2 out of the 4. And then those 2 that I select, the individual within them, I will select them also using the random method. Okay. Consideration in selecting a sample, what do we look, or what do we consider in selecting a sample? 1, you want to decide, or you want to decide whether do you need a random sampling? So what factors will help you to determine that, whether you need random or not random sampling? Anyone? What are some of the factors that will help you to decide whether you need random sampling or not?
Maybe the method you decide to use.
Wonderful. Excellent. So, for example, if you are using qualitative method, you don't need random sampling, right? So, you don't need that. Then, what is feasible? If you are going to use random sampling, is it feasible? Do you know the population, right? Is the population clearly defined that you can easily select randomly from? Is also another point. How do I prevent bias, right? If you want to eliminate, how do I prevent bias can also be one of the key considerations. So you need to be aware of the potential ethnic sampling bias when clients are recruited for special clinic or program. How much time do you have? When you are conducting the evaluation, how much time do you have can also help you to decide which method do you use. Key is to think critically about strategy. So your data collection strategy is also key to guide you in that. What informed choice of sampling? 1, the purpose of the evaluation, right? Type of evaluation design being used, either qualitative, quantitative, level of credibility researcher wants, the audience of the report, and then the resources available, right? Because resources determine how much or how many people you can sample and how much are you willing to spend, right? In either giving them tokens or either giving them some small amount as compensation for taking part in the research and so on and so forth. How big a sample should be? I mean, as you already mentioned, there are two key areas. One is for qualitative studies, saturation is mostly what we use to determine the sample size, right? But with regards to quantitative studies, normally we use calculations and then what we call the margin of errors and then the confidence interval. Is that all right? So which of the, margin of error did I mention is ideal? 1, 5, and 10. Which one is the best? Anyone?
Sorry, which one margin of error would be the best?
The margin of error
so
of
it would be 1 then.
1. Yeah, 1. Absolutely. So the higher the margin of error, the higher the sample size. So take note, right? And then the higher the sample size, the more you are reducing the error, right? Or sampling bias. Is that okay? So take note of that. So for probability sampling, margin of error and confidence level determine sample size. So the margin of error refers to the precision of the findings. And then, for example, 5% margin of error is reasonable and acceptable. A margin of error of 5% means that the actual findings could vary up to all manuals. So, for example, if I say my margin of error is 5%, is that okay? It means that if I come out with the results, let's say I would say maybe 10% of the people like soccer. Is that right? It means that my result can either be 15 or 5 because the margin of error is what? 5%. It can be 5% plus or minus. Right? Okay, good. Yes, Ashley.
Sorry, I might have missed it, but how are we calculating the margin of error to begin with? Like, are we just making up a number for our own objective?
Yeah. You determine, okay, which margin of error do I want to use in my research? So the ideal one is 1%, right? So you can decide, okay, I will use 1% margin of error in my research. It means that I am 99% confident in the result.
Okay.
Right? Or I can decide to say, okay, I will use margin of error of what? 5%. It means that the result that I'll get, I am 95% confident of the findings. Is that okay? So
yes. So we make it up. We're just making up that number. Okay.
Yeah. You decide. It's already there. You are not making it up. It's there. I mentioned that we normally in research we have either 1%, 5%, and 10%.
So no other margin of error. It's just those 3 options you decide on?
Yeah, normally. But you can, okay, say maybe margin of error of 2 or whatever, but ideally it's 1, 5, and 10. Normally 10 is not accepted. I mean, it's not rigorous, right?
Okay.
1 and 5, right?
Okay. That makes sense.
Statistically significant. Yeah.
Thank you.
Thank you too. Any other questions? So the lower the margin of error, the higher the sample size, right? And then they also reduces the bias in the sampling. So let's use this quickly to, I hope it works. Let me use this one and demonstrate what we mean by the margin of error and then the confidence interval. 1 minute. Any questions so far? Let me see. This one is asking for passcode, not this one. Okay, good. So let me stop sharing and then share my screen. Oh, okay, stop sharing. Okay, do you see my screen?
Yes.
Okay, so now we are going to determine, let's say we have a population of, somebody should give me a number. What population do you want us to work with?
Can we make it easy and just do 100?
100, okay. So let's say population of 100. So this proportion always should be 50%. This one is always left at 50%. What margin of error do you want us to use?
Well, if it's at 1,000, I'd say 1% because that's a pretty large sample, no?
Okay, okay. Oh, you said 100, right? Okay, let me work with your 100 first. Then we'll go to the 1,000 and you see the difference. So you want us to work with percent?
Let's do 5% for 100.
Okay, well, 5%, it means the confidence level will be what?
95.
Okay, so let's see what will be the what will be our sample size. So what is the sample size?
80?
80, right? So I mean, it's designed for you. Okay, let's use the 1,000.
So
And
is
then,
that sample size what the system is assuming would respond to the survey?
no. When the sample size is the number of people that you have to interview, so that the study will be representative.
So that 278 is who we select out of 1,000 people?
Yes.
Okay.
So out of the 1,000 people, we have to select either 270 or more.
Okay.
So that the study will be representative. Do
I
you get
get
it?
it. Yeah,
Okay,
I get
so
it.
let's look at something. This is when we are using margin of error of 5%. But when we use the margin of error of 1%, you can see that the sample size will increase. So the lower the margin of error, the higher the sample size. Is that okay?
Yeah, and that's because you'll get a better representation. So there's that.
Absolutely.
Okay.
Absolutely. So when you use the margin of error of 1%, what will be the confidence level?
906.
No, the
sorry,
confidence
99.
level. 99. So just imagine how the sample size has now risen to 944.
Yeah.
So the lower the sample size, the lower the margin of error, the larger the sample size, and the more precise you can get your results. So it means that the finding that you get, you are 99% confident. Is that okay? You are 99%. Can we try another? Give me any other population size.
What if we do 500 and then we do the margin of error at 10%?
Okay, good.
Just to
So
really
500.
skew the numbers.
Yeah, sorry, 500, right? The rest of you, are you following? There's only 2 people that are speaking here. The rest,
I think
James?
math, I'm kind of confused.
Confused? Okay, tell me what are you confused about so that I can explain. That's good.
Just the numbers. I think the way you are using the numbers, that's what I'm not getting.
Okay, let me work with you then. Let's assume, just decide any population that, for example, you want to work with. Just give me any number so that I'll work with you.
Sorry, Professor, I have a quick question. So does it mean that percentage you just assumed, or is there any way you can get to know the percentage that you're going to use? So how do you
wonderful.
Like that percentage generalization, how do you get it? Yeah.
Okay, good question. So let's assume that I want to interview nurses, or let's say even bankers in Susemeri, right? I have to know the population, how many bankers are in Susemeri. That will give me the population. Is that okay? Are you following? Who asked the question? Is it Mary?
Yeah, no, it's Mary, but I'm actually
It's me. It shouldn't matter. I asked the question. How to determine the percentage? Yeah.
So the population, you always get it from either the statistical service or even census, or even you go to, for example, the registrar, right? And ask how many nurses are in Susemeri in total. So that will give you the population. Is that okay? So Mary, just assume that you are the registrar. Just tell me any population that you think maybe are in Susemeri. Or Chidima?
Let's say 2,000.
Okay, good. So let's say when we ask the registrar said we have 2,000 nurses. So now you are going to decide for the margin of error that you want. And I mentioned that the margin of error, we have 1%, 5%, and 10%. Of course, you can just maybe say 2% or whatever. But let's assume these are the 3 key that are common. So assuming you want a very precise, findings, you have to use 1% because you want the result to be 99% accurate. Is that okay? Are you following?
Yeah.
Yes. So when you use 1%,
yes,
then the confidence level will be 99. Then you check here. So you see your sample size. The system will calculate the sample size for you. So the sample size is now 1,785. Is that okay? James?
Yeah.
Is that good? Are you good?
Yeah, I got it right on, man.
Exactly. So assuming that you said, okay, no, 1% is too high. I just want to work with what? 5%. So 5%, what will be the confidence level?
95.
95. So you see that the sample size will reduce. But look at the margin. From 1,000, right? From 1,700 up to 300, the gap is too much. So the higher, that's why we say 1% is like the highest that you can get. And the result is 99% accurate, right? Your findings will be 99% accurate. So these are basically what we use. The system is there. You can also use calculation, right? You can use calculation. So I think I'll pause here so that I will not waste all the time here. Any questions so far?
Sorry, like the response distribution that say 50%, what does that mean?
Random is that's a calculation. So for that one, normally you leave it at that. You don't adjust it. Is that right? It's like the proportion. So you just leave it as that. Okay, let's look at other means by which you can calculate samples. That these are mostly in quantitative research. Is that okay? So there are various calculations. That this one calculation is one of the example. Chi-square NP 1 minus P plus D square N minus 1 plus chi-square P into bracket 1 minus P. So here it will define the various elements here. So the chi-square normally is 3.841 is given from a table, right? That's chi-square. And then N stand for the population size. That's the big N stand for the population size. So if the population size is 200, you put 200 where the N is. Then the P is the population proportion. So which is the 50% you are asking about Chidima. And normally it's around is given as 50%. So you put the P in this equation. And then the D, this is the D square. The D is the margin of error you want to use. So assuming you want 1%, you want 10% or 5%, then you put it there. Then you do the calculation, the mass, it will give you the answer. So I'm giving you this, try it at home. I'm not going to give you any calculation question, but you can try these questions at home, right? In order to be familiar with how to, to know how to calculate sample size. So these are the questions. So look at it, for example, Mr. John is conducting a study among hospital administrative staff in Susemeri. The total population of the hospital administrative staff is 800. Using the formula for calculating sample size, calculate the appropriate sample size for Mr. John's study given the chi-square is. This one is already given. The population proportion is given. The margin of error is given. So now you have your chi-square, you have your N, which is the population, 800. You have the proportion, which is 50%. And then you have your what? D square, which is the margin of error, which is 0.5. So put these figures in the equation and then you try it, right, at home and see whether you get a correct answer. All right. Let's quickly move to.
Sorry, I just had my hand up. Can you go back 2 slides for 1 second? I have a question.
This one?
One more before that. Oh, wait, no.
This one?
Yeah, this one. So the x squared, like the value of chi, is that always going to be given to us? Like we do not get that on ourselves?
Yeah, it's always given. It's in the table. Chi-square is always given.
Okay. And also, are you going to be giving us math questions like this on the exam?
No. I'm not going to give math questions.
Okay. I don't know. Thank you.
I'm not giving you math questions, but you have to know, right? It's something that you should, So that's why I'm giving you this as a, trial, something that you try at home. There are, different methods of calculating sample size, not only this one. Maybe next time I'll give you another different method that you give it a try. All right. Let's wrap up quickly. Do's and don'ts of sampling in reporting, right? What are some of the things that you don't do when you are sampling, and what are things that you must do when you are sampling? One, do identify your sample strategy, right? How are you going to do the sampling? Are you going to use simple random? Are you going to use cluster sampling? Are you going to use purposive and whatever? Know that. Provide a justification for your sampling strategy. Why do you think that the strategy that you are using is the best, right? Sometimes, for example, let's say if you are using snowball sampling, the justification that you can give is that, for example, the population are not in OP, right? So they are not easily identifiable. So you want to use referrer so that they will, refer you to colleagues and others. Do explain how your sample strategy and your sample is related to your methodology, research question, analysis, and findings. So in your report, I'm talking about when you finish conducting the study and you are writing your report, either the findings, right, discussions, and everything. The sample session, these are some of the things you should consider, right? Explain the strategy you used and how is it related to the methodology. So for example, if somebody says, I did a qualitative study, but I use simple random sampling, right away I'll tell you it's wrong. Because qualitative study does not go with simple random sampling. Is that okay? So qualitative study will go with which type of sampling? Anyone? Example?
Can you ask that again?
Qualitative studies. Which are some of the sample techniques are suitable for qualitative studies?
Grounded theory.
Grounded theory is the method or approach of research. So sampling, I'm talking about
random sampling.
Which one?
Random sampling.
For qualitative study?
Case studies.
Snowball sampling. Snowball sampling.
Yeah, purposive sampling. So qualitative study always go with purposive sampling or non-probability sampling. So we can talk about purposive sampling, convenience sampling, case study, right? Normally, sometimes case study doesn't use sampling. Case study and ethnography, sampling is not required in that sense. But for qualitative studies, try and use one of the non-probability sampling that we mentioned. Is that okay? For quantitative studies, you can use any of the probability sampling that we mentioned. Can you name one?
Cluster sampling.
Yeah, cluster sampling. Anyone? Simple random sampling, systemic sampling, random sampling, and so on and so forth, right? So take note of that. So based on your sample strategy or on intentional thought, purposive decision, and avoid convenience sampling whenever possible. So convenience sampling is not right type of sampling that you can get what you call internal validity, right? Convenient basically means you just do with what is available, right? Whatever is available. So it's not scientific. So limit the use of convenient sampling. So do remember sampling in qualitative inquiry is flexible, responsive, and iterative. Don't stop prematurely. So one good aspect or strength of qualitative study is that it's flexible. So even when you are on the field, you can still change your sampling method. Is that okay? Are you following me? It's okay, good. So qualitative studies normally is very flexible. You can change the samples, strategy at any given time. But with the quantitative studies, because you are going to use model, right? You are going to use model in your analysis. Your sample strategy should work with the model that you've chosen. So if you choose, for example, to use with, let's say, logic regression model, you cannot change your strategy on the fold. So this is something that you should take note of. Now, don't worry so much about the size of the sample. Do worry about the adequacy, novelty, and richness of your evidence and creating convenient or convincing narrative for your research. Don't confuse saturation, theoretical, thematic, or other forms. So when we talk about saturation, right?
Head toward Medallion Boulevard, then turn left onto Medallion Boulevard.
Okay. When we talk about saturation, we can have what we call thematic saturation or sample saturation, right? So for example, when you are collecting the data and you realize that the participants are repeating, right? Are just repeating what they are saying, right? Then it means that there's no need for you to collect more data. So you've reached a saturation and you have to stop at that point. If you get more information, then it tells you that you still need to, collect more data for analysis.
Turn left onto Medallion Boulevard.
Let me see, who is that? Let me.
Chidima, can you turn off your speaker, please?
500 meters. Turn left onto Highway 27.
Okay, let me mute. Give me 1 minute. Okay, it seems she's muted. Okay. All right, good. Oh, okay. All right, so just for a recap, convenience sampling is the least desired among all the purposive sampling. I told you earlier on that you don't need to use convenience. Normally, it is done for just exploratory, something to help you to better design your study and get a very stronger or robust sampling strategy. 2, snowball sampling is another common strategy where one participant recommends another. You know this one. Then sample size are influenced by discipline, methodology, topics, and population. So take note of that. And as population size increases, the sample size increases at slower or decreasing rate. Who can explain this? As population size increases, the sample size increases at lower rates or diminishing rate.
So as the population size increases, the margin of error decreases.
Yes.
And so that's why the sample size increases.
Yes. But you see, the increases, you may expect, okay, you should, for example, you will see that if I use, let's say 100 people, and then I use let's say margin of error of, let's say 50, or no, margin of error of 5. And then I get my sample size to be 50. If I add another 100, right? Now the sample, the population is 200. My mind will tell me, oh, because I've added another 100, I should get 50 plus 50 to be 100, right? But that is not the case. It will increase, but not as high as what? As the 50 that I got at the initial stage. It can either increase by 10 or 15 or 20, right? So that's why we said as the population size increases, sample size increases at a slower or diminishing rate. Is that okay? Okay, good. Let's try this.
Sorry, well, just that last question. Can you go back 1 second?
Okay.
But sorry, no, the other one. Yeah. So we would never actually have to like figure out the slower rate because we would just plop in the numbers to that website and it would tell us.
Yeah, no, we will not decide here.
Okay.
Yeah. But what I'm telling you is that when you increase the population, the sample size will increase, but at smaller rate. Is that okay? Or it's not clear?
No, that's good. Thank you.
Okay. Wanda? Is it clear or you need explanation? Okay. Or yeah, we can use this thing to demonstrate it. The web that we use. Let me see if it's available. Let me see quickly. 1 minute. I just want you to get the point. Okay, yeah, it's here. So let me just 1 minute to demonstrate it. What I mean by when the population size increases. Okay, so let's use 1,000, right? Are you all watching?
Yes.
Okay, let's use the same margin of error of 5 and confidence level of let's say 95. So what is the population, what is the sample size in this scenario?
278.
278. Are you sure, all of you?
Yeah, 278.
Okay. That's what so let me ask you, if I add another 1,000, what do you think the sample size will be?
I think the sample size will go up.
Double.
By what? Can you guess?
By
double.
By double.
50%.
Okay. Just mention by double, right?
No.
Is it like
No, didn't you
normal
just tell us
sense?
that it wouldn't be a double the amount?
So normal sense, when we add another 1,000, our mind will tell us that the sample size should double. Is that okay?
Yeah,
that's
but
rational.
that's not right.
But it will not double because
I think it will go by more.
No, by small.
Smaller?
Yeah. No, it won't go. It will add, but not double. So
Okay.
it will be a smaller. So it means that it is increasing but diminishing rate. You get a point. So let's start. Any of you just guess how much do you think when we add another 1,000 the sample size will be?
350.
350. Okay. Any other person? Oh, guess.
It'll go up by 50.
Go up by 50, so it will be roughly 130 something, right? 330 something, right?
338.
338. Okay, Wanda, do you want to suggest something?
Oh, I hit the microphone. But you said it goes lower, right? So it's gonna go under 278, is it not? Yes.
No. It will go up, but at lower rates.
Oh, I see. Okay, that's
Okay. So we
it's
have
gonna be 323.
Okay, 323. Okay, so let's check.
Sick.
Let's check. Let's add another 1,000 to be 2,000, right? We are maintaining the same confidence level. Yeah, somebody got it very close. You understand? So ideally, when you are adding 1,000, your mind will tell you, oh, it will double, but it won't double. It will increase, but at a decreasing rate. Okay, let's add another 1,000 and see what will happen. Right? Any guess? Another 1,000. What would think that the population will be? The sample size will be 360. Okay, we have 1 360.
I think it'll be 480.
480. Okay, we have 2. So let's add another
340.
340. Okay, we have 3. So let me add another 1,000 and let's see what will happen. Hey, Are you a magician?
Okay, see, now I'm lost. Like, how are we getting how are people calculating that number, 340?
Okay, I'm gonna guess. I'm cheating because I'm going on the link he gave and I'm just putting it as exactly he has it here.
Okay, but aside from that, like realistically, I'm actually asking, like, is there a formula that I can calculate that before putting that in? Like is there some kind of like formula that's like not being shown here that's calculating that 341?
No, this system has already used formulas already. If you want to use calculate, then you have to do the manual.
And that's the equation you showed us in the other slide.
The equation. And there are, yes, the equation, or there are more other equations, not only one. So this one is just to explain increasing at a decreasing rate. Is that okay? All right. So let's try this quickly and then we end the class. Okay.
This is crazy.
All right. So who volunteered to read question 1 for us? Anyone? Oh, quick. We have to just finish.
I can do it.
Okay, go ahead. Oh. Okay, go ahead. Oh, who is going to read?
I'll read it. Which of the following is an example of convenience sampling?
Okay. The answers?
A.
Read all the possible answers. You have to read
I think all of the above. D,
yeah.
all of the above. Because it depends on the setting you're in, and in each setting, that's like the first available people you could have.
Yeah. All the above. Question 2, who will read for us? Quickly.
I'll read it.
Go ahead.
A researcher is conducting a program evaluation of a clinic that treats people with depression. They ask each clinician to think about 2 or 3 clients that represent an average client in terms of symptoms, lengths of treatment, etc. What type of sampling is this?
Okay, good. Yes.
A, convenience sampling, B, deviant case sampling, C, random sampling, or D, typical case sampling.
Yes. What's the right answer?
D.
D. The right answer is typical case. So when you are using the average client, it's typical case. Deviant case is the extreme end, right? Typical case is the average. Okay. Question 3. Who will read it for us?
I can read.
Okay, go ahead.
A convenience sample is one that is selected randomly using a table of random numbers, true or false. I am going to guess it's false.
False, yeah. It's false. Absolutely. Question number 4. Who will read it for us, please? Quick. Who is volunteered to read? Yeah, go ahead.
When conducting an evaluation of child welfare supervision practices in one state, the researchers surveyed those involved in an intervention designed to improve supervision. The supervisors in the sample represented what type of sample? A, a convenience sample, B, a snowball sample, C, a purposeful sample, and D, a quota sample.
So what's the answer?
C.
Let me see. Oh, wonderful. I like that. People are paying attention. Yeah, good. Yeah, it's C. Let's look at the last. Is it the last question? Yes. Last question. Who will read it for us?
I can read it.
Go ahead.
Quota sampling. A is an attempt to be inclusive without using random sampling. B results in some groups being oversampled. C can be conducted quickly and easily. D, all the above, or E, none of the above.
Okay, which one? Let me see.
D.
Yes, you are right. D. So that's it. All right. Thank you very much, all of you, for participating. If there's question, comments, I welcome them. If no, then I think we can call it a day. I mean, it's tough doing research methods in the night, right? But we are managing. Okay. Any questions, comments, suggestions?
Yeah, I'm just wondering again about the feedback. Do you need us all to email you again, or what are we going to do about that?
No, only one person. Only one person.
Yeah, I mean like one person per group because there were multiple groups, right? So
multiple groups didn't get the feedback.
I sent ours already.
Yeah, my group didn't either.
Yeah, my group either.
My group didn't get a grade.
Send me email me so that I'll just look at.
Okay, so
everybody has comments.
One person from each group member email you again?
Yeah, exactly.
Okay.
Everybody has a comment. I posted a comment for each person.
All right. Thank you, Professor.
Sometimes I have to resave it again. 23 or so word. Okay.
Have you graded them all, Professor?
Can you read that?
Have you graded all of the assignments? Because my group hasn't even gotten the grade. So I was just wondering if they're all released. Or...
Yeah. I think there's one group that I found. So I'll I'll check it today. Okay.
Okay, thanks.
Thank you too. Are you with Shauna, right? Shauna?
No, this is
Shauna's group?
That would be our group.
Yeah, no,
Shauna will be your group,
talking.
Right?
Yeah.
No, I'm not in the same group as Shauna.
Okay. Because I saw one group. Check and I saw empty, nothing there. Then I went back after my grading and I saw that there's the assignment is there. So I'll look at it and then post it soon.
Okay, I'm just going to email you regardless, but we're a different group than Shauna's.
Okay, sure. Let me know that group. Okay. All right. Any further questions, comments, suggestions?
Sorry, sir. I'm lost.
Yeah?
The feedback that you're asking, is it for the assignment, the critique assignment?
Yes, the assignment. Yeah.
Oh, okay. Are we supposed to reply the feedback that you gave, or?
No. If you don't have a feedback, then email me. Let me check your assignment. Probably, I don't know why it's not opening. It happened last year, so I don't know why, but I will save it in a Word 2003.
But the feedback is for the group, right? Like, you gave the feedback for the whole group, or is it individually?
No, I gave the one who submitted it. But I attached the paper, the marked paper, and asked the one who submitted the paper to share with the group.
Okay, then we'll go and check. Okay, no problem.
Thank you, Dr. Demi. Have a good night. Have a good night, everyone.
It's a good night.
Good night, everyone.
Good night, everyone. Stay safe and stay warm. See you next week.
Good night.
Good night. Let's stop sharing.